All right, good morning, everyone. Welcome to today's class. The first thing I want to do here is just quickly open the floor to check if everyone was able to follow the instructions, get everything installed. So R Studio, the packages installed, and then I guess a way to check if it was installed is if you could load it using the function library. So
Hello,
anyone?
Dr. Leo.
Yes.
In case you're speaking, we can not hear you.
Oh, you cannot hear me? You can hear me? Can other people online hear me?
Yeah, we can
Yes.
hear you.
Okay.
Yeah, we can.
Okay, so maybe it's with Tifton. Let me see. Let me chat. Here we go. This, mm, mm. Um, so in Tifton, Polly, you guys cannot hear me yet. So I guess, well, I'm just gonna continue speaking here so you can see if it works on your side. And I'm just checking here if everyone was able to install everything, any issues. So just a heads up, I work on a Mac and I noticed that Windows users sometimes have some issues, especially if it's your first time using ours, first time installing packages. It may ask you to install our tools as an extra software that I don't think it asks on Macs. So if you use Windows PC, you may have had to install that to make sure your other packages could be installed. And I think somebody had an issue with that and posted on issues on GitHub. So that would be the solution for that problem. And for those that both asked and also helped on GitHub, I just wanted to commend you on that. It's really what I hope all of you can use that resource to get help and also help others. Okay, so Tifton still cannot hear me.
It's solved now. Can hear you.
Okay, perfect. All right. Sounds great. Thanks, Paulie. I was just saying here, asking if everyone was able to install the packages and check if they were installed. At least I think everyone that could hear me at that point was able to do it. Was anyone in Tifton that couldn't hear me before? Was everyone able to install the packages? Or if you were not able to install something or had an issue, let me know. I was just saying that if you use a Windows PC, you may have to install R tools first, especially if it's your first time using R. But Mac users should not have that problem. All right, so in this class, it's going to be really important that we organize our files properly. So it's going to be a lot of files we're going to be developing this semester. And as you're going to start learning, we're going to have a way of organizing them. So I'm showing you how the folder for the course looks like for me. So I do have let's see, if I go one level back, I have a 2025 CRSS 8030 folder. Please, if you don't yet, create one for you because you're going to need that to get organized. In my folder right now, I have the 2024_DSA repository from GitHub, which in your case, yours may say the same name -main, but that's the same thing. And I have a couple extra ones that you don't in relation to my organization of the class. So something that I really want to make very clear is that the GitHub repo and the files in it I will be uploading a lot of files to it very frequently, and you're going to be, well, you just kind of like manually download it, but pretty soon in this course, you're going to connect your local Git to that GitHub, and you're not going to need to download manually. It's going to be using Git to do that. And we're going to get to that point when we get there. But what I'm trying to say is the files in this 2025_DSA GitHub repo are just the files that I'm sharing with you. I do not want you to simply work off of those files in that folder. So what I want to ask you to do always when I share files is kind of think of this as your your repository for files I want to share with you. But when I do share them with you, I will want you to download it and then copy from that folder and then bring it to your own folder that we're going to create. So just as a heads up. All right, so assuming that everyone did not have issues with installing packages, and so we don't have to talk more about it, I want to go inside of my 2025 DSA. I do have a few more folders than you at this point, but you should have 01 packages and 04 class code, right? So what I want to ask you to do is on this 04 class code, you open that, you're going to see this R script called 0109 intro to R partial. I want you to copy this. So again, I want you to create a copy of this that you will make your changes to it, right? So do not just double click on this, launch R and start from there. So copy this, then go back one level, go back another level. You should now be back at the main folder for the class. Here we're going to create a folder or a subfolder. So I want to call this 01 underscore intro. All right. So on this 01 underscore intro, I want you to go in there and then just paste this partial script that you got from 2025 DSA. All right. So just quickly redoing this one more time. You got your 2025 DSA main, you went in there, you went into the 04 class code, you copied that R script, you went back 2 levels, created a 01 intro at the main level of this class, and then you pasted that partial script right there, right? Okay. So I'm gonna, especially if you've never used R, the way that I introduce topics is sequentially and slowly. I don't show you everything at once to not overwhelm you, but we go step by step. So the way that we're starting this is going to be with this R script. I want to ask you to just double click this R script and it should launch a new RStudio window, or maybe if you already had RStudio open, it may launch on that window you had open. Let me increase my font size here. Well, first off, if you cannot see my font here, the blue with the light blue with a dark blue background, let me know. I can change that. But otherwise, we're going to start here. Okay. So we have an agenda for today, which is our intro to R class. So this is assuming you have zero knowledge of R. If you already have knowledge in R, this is probably going to be something you're already familiar with. So just bear with me if that's the case for you. Okay, so I just have a few housekeeping items that we created that folder, and then we created the script into it. We just did that. Again, this is here, the website for the course. If you have not bookmarked this yet, I will highly recommend you do, because we're going to be using that a lot. So just make sure you do that. I will be sharing with you partial scripts and also data sets we're going to be working with through GitHub. So just as a reminder. And then on the YouTube channel, you're going to have the recordings. Just a very quick thing about YouTube is the first thing when I get back to my office is I upload that video to YouTube, and that should be available within 20 minutes after I do that. Sometimes, for some reason, I may have to run and I may not be able to immediately include that link on the website and refresh it for you. So if you ever go to the website and there's not a link, a YouTube link yet there, go and check YouTube channel, because it may be there already in the channel. I may have just not created the link on my website. So just as a heads up. Okay, so before we start really talking about R in RStudio, I do want us to set up a few or change a few defaults here of RStudio. So the first one, we are going to, so our RStudio has this default behavior of saving your, or restoring and saving everything you do in a session. If you close that session, RStudio wants to save it, and next time you open RStudio, wants to load that back to you. which sounds useful, but it's really not very reproducibility friendly, if that is a word. So we're going to change that behavior so it does not do that when we close RStudio. So to do that, you come on here on Tools. We're going to go on Global Options. Under General, Workspace. So General tab, Workspace. And for me, it's already unchecked. If it is checked for you, please uncheck that. And if save workspace to our data on exit, if this is, for me, is already set up because I've done this before. So for me, it says never. If yours says something else, change it to never. Okay, so just very quickly, let's go through that again. Let me just cancel out. So I went on the tools option here on top. I went all the way down to global options. On the first tab that it pops up is general. So you're already in the right place. And I just unchecked the restore our data and changed the save workspace to our data on exit to never. Yes.
Dr. Bastos, why are we doing that?
Sorry, for those online, give me just a sec. I have a question here in class. Charles, you want to speak up? Because maybe other people also.
It's like why do you think it's not space like
Okay, so Charles, right? So Charles has a question here about why do I think that's not reproducible? So we never really want to have these ghosts of objects we created in the past, because you may create an object today, right? And let's say that, I mean, maybe we can hold this conversation for when we are already familiar with the nomenclature, which is not quite yet, so everyone can understand. But we're going to talk about that again on our next meeting on like about it's going to be all about reproducibility and some good practices for that. So we'll come back to that. And I just don't want to spend a lot of time on it right now, because you know, if you're new to R, you may not understand what I mean when I say certain words. But that's a great question. Yeah, but we'll come back to that on Tuesday. Online, I think somebody had a question.
Yeah, I was just asking why we are unchecking the box.
Yeah, so Comfort, I think your question is the same as Charles asked here. I will pin this question for next class because we're going to be talking a lot about reproducibility. And I just don't want to spend a lot of time on that right now, just because, you know, if you're new to R, I may be using words that you don't know yet what they mean. And so I think it's, we're going to address this on Tuesday for sure, but that's a great question. All right, in Tifton, we have a hand raised.
Yeah, so I was asking, when you uncheck this box, does it only work when you open let's say the intro studio, or it affects all your work in R? For instance, if I have my own data and I need this function of R and I want to check it and then I open my own data later, does it also apply to that?
So it is a global option, so I believe it would apply to everything that you are using R for. Yeah, if for some reason you don't want uncheck it, I will leave it up to you. Although I would highly recommend you do not rely on this feature if you want to make sure your research is reproducible. It is for some reason RStudio has this option, but even RStudio researchers caution against having this option on. So, you know, we can talk more about this on Tuesday again about the reproducibility aspect and why this can be a problem. But yeah, if you want to leave it on your side, that's okay. I would just caution against that habit, because at some point I'm sure is gonna cause you some issues. All right. So again, I highly recommend you follow these. We're gonna see why that is on Tuesday. But if you don't want to, I mean, you know, you can do what you wish on your computer. But yeah, a good reproducibility I guess, approach would be to follow this unchecking here. All right, so the next thing is I want you to be able to see the outline, and we're going to talk about what that is in a moment. But for us to make sure that we all can see the same outline, I want you to go again on Tools, Global Options. We're going to go on R Markdown. Let me make sure I go to the right place. So Show in Document Outline. Yeah, so Show Document Outline by default. You can click on that. And then Show in Document Outline, you want to make sure you have sections and named chunks. Again, for now, this may not be making a lot of sense to you what this all means, but it will soon. So again, I went to Tools, Global Options. I changed the R Markdown tab here on the left, and then I changed the option where I checked Show Document Outline by default, which this may have already been checked for you, but then make sure you select here Showing Document Outline, Sections, and Name Chunks. And then once you do both of those things, I mean, I exited mine and went back, but in your case, make sure you click Apply before you exit this window on both of those changes, right? So again, R General, uncheck Restore Our Data, and say to never exit and never save on exit. And then on R Markdown, under Document Outline, you have sections and name chunks, and you have that checked there. And then make sure you click Apply. And then you can do OK, and that closes the window. All right, so for today, my learning objectives, or somebody had a question?
Yes.
Oh, okay, somebody online had a question. Go ahead.
I think we don't have most of the options on the R Markdown. You don't see the
Windows,
logos.
we have Windows.
Yeah, in Windows.
Okay, do you have, what options do you see there? Let me open mine again so you can compare. So global options are Markdown.
We don't have the document outline.
Thing.
Anyone here in class has Windows? Is using Windows?
Yeah, we have like so in the document outline section. It will be
It's
in the third.
there.
Yeah, it's because they have a different version of our studio. That's my guess. Because I'm using both Windows and Mac. On my Windows, I say fine, but in my Mac, it's an older version of our studio. So I think that might be the reason. And I don't see in the Mac, so I think that might be the reason. So I guess they need to update to the newest version. But that's my opinion.
Okay, so for those in Tifton that do not see this, are you using our studio version that is like you have not updated recently?
Yeah, it's
Yes.
not updated. It's required that administrative thing. We'll do that later in the class.
Yeah, so it's probably related to that. Yeah.
Thank you.
All right. Well, thanks everyone for your thoughts and helping out others as well. All right, so today my goal is to help you become familiarized with using R in our studio. We're going to learn about R terminology and syntax. So this is where like we're using the words to refer to certain things is going to come into place. And if you're new to R, it's important you know how we call certain things. We're going to understand the differences between a few different object types. And then we're going to create a simple data explorer with numbers and graphics. And then learn about RStudio projects. We're going to create our own project and set up our proper subdirectories for that. Okay, so before I move on, I just want to show you here. So that second option we changed on the global options is to see the outline. So on my RStudio, if you see there's that outline icon right there. If you're not seeing the outline yet, you can toggle that on. It's going to show you the outline. You can resize it if you want. I'm going to remove the outline for now, but this is what I meant by outline. It's just that whenever you start creating very long and complex scripts, it is very useful to have an outline to navigate that file. So this is what I meant by changing that option there. All right, I'm going to hide it away, but that's where it is. Okay, so let's start talking about R in RStudio. So why using R specifically? I don't know if this is still practice in grad school anymore. I have not taken classes in a while. But at least when I was going through grad school, some people would teach using SAS, some people would teach using MATLAB, SPSS, other software, and they're all great in their own ways. But the problem is that we can use them at no cost because we're at the university, but they're really proprietary software, right? So once you graduate, guess what? You're going to have to pay for it. So one of the reasons why I like R, and of course, R is not the only language that follows this. Python is another great example. But here we're talking about R. So I really like it because it is free, right? You're learning this tool. Once you graduate, if you go to a company or if you open your own company or if you go to a place where they don't offer those private proprietary software, R is going to be free regardless where you go. So that's always a great benefit. I really enjoy using open source free tools whenever I can, and R helps me to do that in a lot of different ways. For me as well, it's very useful that it runs on multiple platforms. So if I was, for example, a SAS user, maybe I would have to do some workaround to get it installed and working on my Mac, right? So for me, when I made the switch, I guess, from proprietary to free software, being able to install on a Mac or even other operating systems was a big plus for me. R has a huge online community and support. Again, I'm making a lot of references to SAS because that's how I started when I started my master's. And I found that if you ever need help in SAS, it's kind of clunky. Like you Google something, it's going to be like a technical, blog post from SAS, which there's a lot of good information, but it's not easy to find quick solutions to problems. R has a huge online community. If you Google whatever, like how to do X in R, you're going to get a ton of Stack Overflow posts related to that. It's easy to get help. There's a lot of people developing software for R, right? So new packages is kind of the way that people do it. Always new packages come in available. So it's a really awesome community to be part of. And speaking of packages, there is continuous development of so many different packages, right? So there's packages that we're going to be using a lot here, and most of them are created. I mean, the major part of the ones we're going to be using are going to be created by RStudio or POSIT now as they're called. But there are many others that are developed by people just like us, right? A researcher or maybe a graduate student that has a project that you have your workflow that you develop and you think, you know what, maybe somebody else could benefit from these. And then you can publish that as a package. So there's always something new coming up and something new to learn. And then reproducible research. We're not going to talk a ton about it in this class today because we have a full lecture on it on Tuesday, but reproducible research is a big thing, right? So if you've never heard about this, in very simple terms, reproducible research is you creating an analysis in another person or even your future self being able to fully reproduce that if given the same data and the same code, and of course the same software, in this case using R and RStudio and some packages. So I don't know if you've been familiarized with this topic enough, but this has been a big topic across different disciplines in research, where there has been some very big cases where research was done, a very big important topic was discovered, a solution for a very important topic around cancer was developed. And then people started asking for the data and the code to try to reproduce that same result, same algorithm, and they just couldn't. The only way that they were able to fully reproduce the results of that team that first published that paper was by making some deliberate errors and mistakes in the data and analysis, which is horrible, right? You don't want that to be, especially around something so important like cancer research. In our case, nobody is dying on the surgery table. Hopefully, we're all talking about plants, maybe some pathogens, maybe some insects, maybe food science. But really, even though we don't have the urgency of reproducibility, it's still very important, right? So we're going to talk a lot more about this on Tuesday, but using a programming language and especially with Git and GitHub, is a great way to make sure your research is reproducible. And in the case of programming language, specifically here in R, one of the reasons for that is because everything we do, you're already documenting what you're doing through the code itself, right? Imagine you would do something very complex using a drag and drop, click and point type of software. Imagine you have, I don't know, 50 steps for that analysis. Unless you're taking very detailed notes of what you're using, what's the input, what's the output, what arguments are you changing, what options are you choosing, unless you're taking those notes, I would bet your analysis is very unlikely reproducible, right? Now with code, you can have very complex workflows, but the code itself is the documentation of what you're doing. You're using functions, using arguments, it's all explicit in there. So it helps from that perspective as well. So that's why I use R. Again, R is not the only one. Python, Julia, other languages are also very useful here, but we're going to be using R this semester. All right, so why RStudio then? RStudio is what you're seeing right in front of you. And it's one of the integrated development environments, or IDE. You're going to hear this word perhaps in other contexts. RStudio basically brings together a lot of different components of an analysis all in the same window, right? So right here on this, at least the way that I have mine configured, yours may be a little bit different depending on if you've changed things. But for me, the script is showing up here on the top left. The script is really just text, right? It's just, you're using functions, we're going to write on the script, but that is not where the magic happens. For you to have any function actually have an impact and do what's supposed to do, you have to send it to the console. So the console is this left bottom panel here. So we have the script, we have the console. As we start developing the script and creating objects, those objects will appear here in our environment. And then, so on the bottom right and on the bottom left, we have a few things going on. They're going to be really important for us. So we have this Files tab, which for now, it is showing where our script is. This will become more important as we increase complexity in the coming lectures and labs. We have a Plots tab. We have a Package tab that shows all of your install packages. We have this help window, which is going to be really helpful as we ask for help from specific functions and so on. So really, RStudio brings all of this together in a very seamless way. When I first learned R, my instructor of that course, they were a huge fan of R by itself. And if you've ever done that, it's really not very friendly, I guess, because then you have your script as one window, completely separate. And then you have your R, which R is where the console is. This is what R is. Everything around it is just RStudio bringing pieces together for you. So if you just use R by itself, you have a window for your script, a different window for the R itself, which is the console, and then you may have different windows showing you plots and files and things like that. So RStudio just brings it all together into one place, and I think it really helps a lot. All right, so I think that's probably enough only talking. So we're going to start coding here very slowly, but we're going to start coding. So this, again, is an R script file. We know that, well, I already gave you the file, so you did not create it, but it is a .r extension. That's what an R script has as an extension. If you would have created this, if you come here on the plus, you click on here, it would be the first option. There are other types of scripts that we're gonna learn and actually use just them after some point, but I wanted to start basics, so we're starting with just an R script here. In R scripts, if you want to add a comment to it, so let's say I want to write something that is not code, that is just like language, you would have to use at least one $, one hashtag here. And that would make sure that R ignores it. So if you send that line to the console, R is going to ignore it. It's not going to try to run it. If you write, like, if I write something here, and then I run this line of code, it's going to give me an error because this is not R R language, right? So if I want to write a comment, make sure you use a pound sign, a hashtag. Okay, so let's start very slowly here and start introducing the concept of an object in R. So let's say, you know, if I just put a number here, so you can think of R is also in its simplest way, it's a calculator, right? So anything you type in Excel, you can also type in R using very similar syntax. So let's say I just have a number, 45. If I just type that number, the number itself is not doing anything. I'm not asking R to do anything with that number. But let's say if I wanted to do a very simple math equation here, if I just want to divide this by 13, so just use the same division symbol you would, and I just type in 13 here. Now, for me to actually see the result of this, this has to be sent to the console. I'm going to show you, if you're not using R yet, you haven't used R, you probably don't know this. If you're using R already, you most likely already know about this shortcut, but a very useful shortcut we're going to use all the time is, at least on Mac, is Command and Return. If you're on a Windows PC, it may be Control Enter. You can try that and tell me if that works. But so if you have your cursor blinking on any given line of code, and so it could be at the end, it could be at the beginning, it could be in the middle, you could have selected the whole thing. It does not matter. If you push Command Return or Control Enter, it's going to send whatever you have on the line of code to the console. So here's where it's sent, and this is the output. So this is just where that calculation, the result of that calculation shows up in the console, right? All right, so let's say that for some reason, this specific calculation here or the result of this specific division is important for me, and I want to be able to recall it in the future, or to bring it back into something that I'm doing afterwards. We can assign this result to an object, okay? So let's do that. We'll type with me here. So we're going to call this object A. And then the way that we assign something to an object is using the assignment symbol, which in R is the lower than dash. So lower than dash means is the assignment symbol. So let's do the following. I'm just going to copy here the 45 divided by 13. You can just type it out if you wish, and then paste right there. Okay. If I run this, a couple things happen. So one of them is it sends to the console, right? So I see there, I did not get any errors, so it did work, but it did not print the result for me. Instead, it created, if you notice here on our environment, it created this A value, and it has a number saved in it. So we created this object called A that is basically, all it is just the result of this division. One way to check what this object is to print this object. If you use Python, you need to explicitly call a function print to print something. In R, you can just call that object name and that's going to print. So if I just type A, and if I just then do a command return or a control enter, notice that it goes to the console and then I get back the print. It prints back to me whatever A has. Okay, so a couple things that I want to notice here. Perhaps out of just my habit, when I learn R, I learned to use the assignment symbol this way. You may see, and you may use yourself, the equal sign. Python would be an equal sign. You can also use the equal sign in R. It will work the same way. I personally am going to stick with the dash, the less than and dash symbol as my assignment, because I think it makes it more clear when you're assigning something to an object, and then inside functions, we use the equal sign. That is just my habit. That's what I'm going to do. You're welcome to do differently if you wish, but that's just so you know there are two ways of doing the same thing. All right, so we created this object A, and all A is just the result of this division, which is 3.46 and other numbers there. Now let's start increasing a little bit the complexity here. So, okay, A has a single number. What if I wanted to assign multiple numbers to an object? Right? And I want to call that B. So if you come right below that line of code there, you can just call this B. Let's use the assignment symbol. And let's say I wanted to give three numbers, 10, 15, 5. All right. If I run this, it's going to give me an error. And the reason for that is that a lot of times in R, you have to bundle things in one and give it, even if it's multiple pieces. And the way we do that in R, and you're going to use this function a lot, is a function called C that stands for concatenate. So if you type C, open parentheses, and then make sure you add a closing parentheses after the 5, this C function is concatenating three numbers and giving that to the object and assigning that to an object called B. So if you have a cursor there, you push command return, it goes to the console. Now let's print B. So if you just type B and send that to the console, it's just going to print its contents. It has three numbers in it. So again, if you're giving multiple pieces to R and you're getting an error that you're not sure what's going on, maybe you're missing a C function. That's a very popular, common function you're going to be using throughout this course. All right, so up until this point, we created an object that has one number. We created an object that has three numbers. Now let's create an object that has a word. So I want to call that C. We use the assignment symbol. We need to, well, let's say if I just try to type here precision, or let's do data science. Or just do data science, right? So a couple words, if I just give it, and you may think, well, maybe we should use the C function here. Well, let's see what happens if we try to run this. Okay, we got an error, right? So the way, every time that we have characters or words or something that is not a number that we want to use in this case, assigned to an object, we need to wrap it around quotation marks. So I'm going to start a quotation mark and make sure you close that quotation mark after science. So now this is a character. This is a string that we're assigning to an object. So now if we run that, it goes to the console. We notice that C popped up in our environment. We created that object. And now if I just print C, so if I do C and I run it, it gives me back data science, right? So we started very simple, just assigning a single number. Then we increased a little bit complexity by assigning three numbers. And then we saw how to give it a single word. You know, I don't have this next thing here on my teaching plan for today, but let me just pose you a little challenge here. So let's create an object called C1. And I want to give it two strings. So let's give it data science and maybe stats. How would we do that? What do you think we need to do to give it two strings? Yeah, I heard somebody saying the C function. That's right? So because we're given two pieces, we would need, so I'll give the assignment symbol. We would have to use the C function and then have data science as one of the pieces, get outside of that quotation mark, give it a comma, and then give the other piece stats. Right, so if we run that, the C1 object pops up in our environment, and if we print C1, it gives us two strings. Yeah, so just keep in mind that every time you're trying to give more than one component to an object, you will have to use the C function in this context. Okay, so we created objects, right? So objects, every time you create an object, you're going to have an object name. You're going to have the assignment symbol or the equal sign, and then something to the right of that assignment symbol. This something to the right now, it's been something very simple, right? A number, three numbers, a string, two strings. but it could be a lot more complex than that. And we're going to see that complexity as we evolve here in the course. Okay, so there are many object classes in R, but there are a few that are very key for you to be familiar with. A couple that I just want you to be aware they exist, although you may not use a lot. So let's get into that. So the first one here is a data frame. A data frame is the most common object class, object type you're going to handle in this course, and most likely in your research as well. So let's create a very simple data frame here. So I want to create this data frame and assign it to an object called D. So we start calling just D. We use the assignment symbol. And to create a data frame, we're going to use a function called data.frame. There are other functions we could use here. There are many functions that we could use, in fact. And as you're going to learn in programming, there are normally many different ways of you doing the same task. I'm showing you one way to create a data frame. So let's use data.frame function. So here we need to give the column name and what that column will contain. So I want to begin by creating a column that's going to be named number. So we're going to say number equals to, and then I want to, under this column, I want to have all the values that B has. So I'm going to say number equals B. Then the next column I want to create, for us to create another column here from right off the bat, we need to give it a comma. I want to ask you to hit return just to break code and be a little bit easier for you to see what's going on in the structure of it. And I want to call this next column ID. Under ID, I want to give it the contents of the object C. So before I go ahead and run this, a couple of things that I want you to be aware of. So we're creating a data frame. The words number and ID, I'm creating them. They don't exist yet. But under the column number, I want to bring all the values that we already stored under the object B. And under the column ID, I want to bring the values stored under object C. If you run this, it goes to the console. And then let's just go ahead and print D by just typing D and then sending to the console. So this is a very simple data frame. We have 3 rows and we have 2 columns. The reason why we have 3 rows is because the object B had 3 numbers and we assign that to this column number. So you see the 3 numbers there, 10, 15, and 5. And then the ID column, notice what happened. R started this data frame with 3 rows, but then we gave C, which was just one value, right? We just had one value under C. It basically recycled that value for all the 3 rows that were there for the number column. Now, if I came here and just to make sure you understand, number and ID are the names that I gave to the columns that we're creating. B and C already existed. If I come here and I use, I don't know, let's say I use an object called M, which does not exist. We did not create an object called M, and I run this, I'm gonna get an error. And it is telling me object M not found, right? So B and C were the things that we created already, and number and ID were the names we were given that were not objects yet. Just to make that clarification. Also, this may be a good point to tell you that R is case sensitive. So if you create your object as lowercase c, and you come here and you say ID equals uppercase C, is not going to find it. It's not the same thing. So that could be a very easy mistake that we make in the beginning, is to forget that R is case sensitive. Okay, I want to take a very brief second in case anyone has questions.
Let's say you only use C1 for ID, which was
Okay, so Charles is asking, what if we wanted to use C1 instead of C in this case? You know, the beautiful thing about programming is you can try it and you can see what happens, and we can learn just by trial and error, right? We're not breaking a computer, we're not messing anything by just trying. So let's try and see what happens. So if instead of C, I put C1 here. In this case, it's giving me an error. And the reason for that is because number has 3 values and C1 has 2. So if we had 4 numbers under B, this would have worked because it would have recycled both values on C1 and it would have worked beautifully. It did not work in this case because 3 and 2 R does not know how to reconciliate those two separate things. But that's a great question, and I do encourage you to try things when you're curious. That's a great way of learning. So I'm just going to delete that one and rerun this to make sure that I have a working object named D. Make sure you do that on your side if you played with the C1 as well. All right, so this is a very simple data frame. We're going to start working with a lot more complex ones as we move forward, but I wanted to introduce you in a very, very simple way. Okay, so the next object that I want to introduce to you is a matrix. I particularly do not use directly myself a lot of matrices in my workflows. However, behind the scenes, there's a lot of matrix algebra happening when we do modeling. So I just want you to be aware how they look like and that they exist in R, although I don't expect that you're going to have to use them directly as often. So let's create an object called E. I want to create a matrix and assign that to this object. We give it the assignment symbol. We're going to call this function called matrix. So this function has a couple of arguments. So the first one is data. So this is going to be what we give for the matrix as what I want to be in this matrix. I want to give it the object B twice to have that populated twice because B only has 3 numbers. So I wanted to have that 2 times. Because I'm giving B twice, we're going to need to use the function C, right? So call function C, and then inside of it, we just type B, comma, B. Notice that I'm not putting B in quotation marks because it's not a string. It is an actual object that we have in our environment. So let's just go ahead and try to run that. So we ran, and let's print it now to see how it looks like. So notice that it basically created a matrix with 1 column and 6 rows. If I want to change that behavior and have 1 column with 3 rows instead of 1 with 6 rows, we can come back here on the matrix function. Right in between these 2 parentheses, I add a comma, and it has an argument for n col, for number of cols. I'm just going to say 2. So if we run it now and we print it, this is what we see, right? So we see the 2 columns with the values of B repeated in both of them. And a couple of things that I want to notice here. First, more generally, every time, another thing that, another quality that RStudio as an IDE has is that it gives you syntax suggestions, right? So I think I did not show you, but maybe you notice. If I start typing the matrix function again, it's giving me a suggestion. If it's not giving you yet, you can hit tab and it will give you that suggestion. And if you click that, so let's say I want a matrix, I click on it. And if I click tab again inside, it's going to show me what arguments it has that I can change. So it's giving you suggestions and color coding them, which is very useful to have. And we're going to talk more about that in a second here, but I just wanted to bring that up. Also, very specifically to this case of a matrix, notice how matrices print differently than data frames. Data frames have a column name, and they most of the time do not have a row name. So we had here number and ID, and we did not have anything on the side. Matrices have this, they don't have column names or row names, they just have the ID of that. So in R, and we're going to see this again very soon in this exercise, this notation of placement. So let's say if I use here the brackets, the first location, so you don't have to type this, I'm just typing out to show you. So with this notation here in R, if you're using this to refer to a position in a data frame or in a matrix, the first number is going to be the row number. You can see here, this is row 1. The second number is going to be the column number. You can see here, column 1, column 2, row 1, 2, 3. So this is why the matrix is showing up this way. It's just telling you what is the position. This is completely all numbers for column 1, all numbers for column 2, and so on. So just so we understand that syntax. All right. So the next thing here is I want to create a list. We will use lists when it gets to iteration and automation of some tasks. This is going to be later in the semester, but we will use a little bit of lists, not a lot like data frames. We're going to use data frames every single day. Lists we're going to use maybe in a couple of exercises, but I do want to introduce you to them. So let's create here an object called f. We use the assignment symbol. To create a list, we're going to call this function called list, which is very intuitive. And then, so in the list, one of the benefits of using a list is that you can have different object types as part of that list. Even if they don't match, like if one of them have 3 values, the other one has 2, there's no way to reconcile those 2 things. A list takes care of that. So the way that we do it is a little bit different from a data frame. But let's say I want to have a component of my list that I want to call number. On the data frame, when we were doing a data frame, we just named it number. Here on a list, we have to wrap this in between quotation marks. So it is a little bit of a lack of agreement on how to code, I guess, when between data frame and lists, but it's just the way it is. And we're not going to be using lists too many times. So, but just so you know, so let's say I wanted to create a component of this list that I want to give a single number, and that would be the number that we assign to object A. We're just going to say number equals A. I'm going to give it a comma and break line. So hit return just so it's a little bit easier to read. I want to have another component of this list that I'm going to call numbers. So open and close quotation marks and type numbers. And I want that to be equals to the object B. I want to give it another comma here and create a third component of this list. I want to call this word. So let's just use the open and close quotation, type word. And I want that to be equal to the object C, which only has a single word. And finally, I want to give this list, the fourth component of this list is going to be a full data frame. So I want to type here in quotation marks, data frame or just data, and then say equals to the object D, which is where we had that data frame. So notice that A is a single number, B has 3 numbers, word has 1 string, data is a data frame with 2 columns and 3 rows. So they all have different dimensions, but a list can accommodate that. So if you run this, if you got errors here, make sure you have all of your quotation marks opening and closing. Make sure you have your commas at the end, except the last one. So if you run it, and then let's print what F looks like. So if I just type F and send that to the console, I'm going to increase mine here so we can see the whole thing. Notice that it has components with the numbers or with the names that we assign. So number is the first component. This is the value it carries. Numbers, plural, is the second component that has all the values that we store in B. Word has that data science word. And the fourth component that we call data has a full data frame. So this is what a list looks like. And again, you're not going to be using too frequently, but I still wanted you to be aware of it. Yes. If it gives an error, I mean, we have to see what the error is, but does it say anything on your side? Okay, so the problem may be at this level. Perhaps you're missing a comma, or it could have been when you created the object D. I think Arminder is going to be able to help you out there. While Arminder is, sorry, what's your name? Aita? Okay, Aita. So while Arminder helps Aita, anyone else online or maybe here in Athens has problems or issues or questions?
I just have 2 questions. They're kind of general questions. Do you always need to run script before you can print it?
Yeah, so so if, let's say so for example, we're gonna create an object that we're gonna call B2 at some point in this script, but we have not yet, right? So if I look in my environment, I do not have an object called B2 here. So if I type B2 at this point and I try to run it, it's gonna say that it did not find that object, right? So you have to first create it, and once it is created and in your environment, then you can print it by just calling its name.
Okay, and then my second question is, how important are spaces? Because it's like, I don't know, that down the line, spaces will become really important, because right now, I'm noticing if I include spaces or don't include spaces, I get the same results.
Perfect. Let me repeat that for those online. So, sorry, what's your name?
I'm Sam.
Zach.
Yeah.
Okay, so Zach asked two really good questions here. The first one was, do you have to create the object before you call it, before you print it? The answer was yes. And then the second question was about spaces. As far as I can think and relate back to my previous experience with using R, I don't think there is any place where adding a space or not makes a big difference. I don't remember of any case. However, there are coding scripting styles that we can use. So Google has a full scripting style that they recommend for different programming languages, including R. And one of those guidelines that Google, in this case, provides is, for example, to add a space when you use like before and after an equal sign, right? So there are style guides that we can use just to make your code more readable and reproducible. I mean, reproducibility wouldn't change necessarily. It was more for it to be more human friendly and human readable. So whenever you see a space that I'm adding is mostly because of that. It's not, so let's say, and this is a really good point to show as well. So let's say you're seeing how this, well, I'm gonna leave that up there. I'm just gonna copy and paste and repeat it so we can compare kind of side by side. I could have done this, and not just with the spaces, but I could have also not broken line, not have broken line. I could have just done this, which maybe in this case is not the worst to read, but there are cases where breaking line and adding spaces really improve your readability of your own code. So, I mean, and here you can kind of already see, right, which one is the easiest to read or to make sense, right? I think, to me at least, this one is a lot easier to see what's being created and what's being assigned to what. And here is you kind of have to like, get closer attention to really see what's going on. So it's just a coding style. Yeah. Yes. Oh, yeah. Okay, let me open up my. Yes, Tifton.
Dr. Bestos, how we can learn more about the function we are using, like what is what in the function?
Perfect. That is a great question, and you're actually anticipating what we're going to see in the immediate next step. So let's just hold on for that for 30 seconds, and we'll get there. And if after that you still have questions, please feel free to ask that again.
Thank you.
All right, so I'm just going to delete this second F here. It would produce this, it would work the same way. It's just a readability difference there. And I'm also deleting the B2 that I was given as an example. Okay, so the next thing we're going to be talking here is about a function. We've used already functions, so I think you already got an understanding of what that is, what it means. But really a function is going to be a word, right? So we've used already list, matrix, data frame. So you can see that the commonality or the shared commonality between them is that there is always a function will always be a word followed by opening and at some point closing parentheses. That's how we know it is a function and not an object, right? So for example, let's call here the function mean. So let's say I wanted to calculate the mean of all three values that we stored in the object B, right? So we'll come here and we can just say mean of B. If we run that, the value is 10. If I just print B again, just so you remember what B was. So B had three values, 10, 15, and 5. The mean of those values is 10. Now, so a function, very simple concept, right? That's what it is. Now we're gonna talk about arguments, which was the question that was previously asked. So how do we know what arguments that are? How do we change them? How do we know what the function is expecting? So one thing here, I'm gonna type again mean, and instead of just typing B, I'm gonna hit tab. So we see here there are these two options. The first one is the most obvious, is just x equals to. So x is gonna be the object you want the mean of, right? So the object that has values you want the mean of. So if I say mean x equals b, it's the same thing as mean of b, but it does have this argument here. Now, how would we know the behavior of a function, what arguments it has, how we can learn more about this function, what it does? There is a function that's called help. So if we ask the help, and then you have to give the function name that you want help for within quotation marks. So let's say I want to know more about this function mean, I would say help mean. You don't need to add the parentheses here. If I run that, it should have popped up here on the top, on the bottom right part of our studio under the help tab. So you see here, it gives the function name. It's telling me what package this is coming from. It's coming from the base package. Normally the help of functions will give you a description telling what it does. It shows you some usage. It shows you what arguments it has, what they mean, and how you can change them. So let's say X here is the argument that is the first argument that we give of the object or number or sequence of numbers we want the mean for. It has this option for trim. I'm not going to talk much about that. Also has this option for na.rm. This is going to be a very key argument across different functions, different statistical summary functions in R, that I'm sure you're gonna run into issues with it at some point. And we're gonna see why that is. But basically na.rm is telling R if you want to remove na values, if there are any, before calculating, in this case, the mean. And the default here, I think, is false. So we can see what is the default behavior by coming here on the usage and looking here. So the default here is for trim to be equals to 0, na.rm to be equals to false. So meaning if you have an na in your data and you're asking for the mean, it will not remove that na before it gives you the mean, and that has implications. So let's talk about that for a moment. If you come under the argument again, or under the argument section here of the script, let's create another object. I want to create the object called B2, where we use the assignment symbol. And let's use the C function again. We're going to give the same three numbers that we gave to B. So that was 10, 15, 5. And then we're going to add an extra one here, which is going to be an NA. In R, NA is coded as uppercase NA. And you see it is properly coded because it looks the same color as the numbers. If you just type lowercase NA, R does not see it as an actual not available. It just thinks that it is an object that you have in your environment, and if you don't, then it doesn't run. So uppercase NA to make sure it is a missing point, right? So if I run here B2, it popped up in my environment. If I print B2, I see now that it has three numbers and it has an NA, a missing data point, which you will have for sure in your research at some point, unless you're working with something very highly controlled. Because plants die, deer love to eat plants, love to eat our studies. You know, your greenhouses, you may have something happen to your pots, your bacteria in your lab may die as well, may not come up, may not grow. So you will have NAs in your data frames for sure. So this is a very simplistic example, but that trickles down to that key concept of having NAs. You're gonna likely run into issues. What do we do about it? So let's use that and show how arguments play a role. All right, so now I want to get the mean of B2. right? So let's just say mean B2. If we run that, it tell me that it is NA. So R has this behavior that if you are extracting a summary statistic, like the minimum, the mean, the median, the maximum, standard deviation, things of that sort, and all of those have functions for them. We're just looking at the mean function at this point. But every time you're using those types of functions, if you have an NA in that data that you're asking for to the summary, it will return you an NA back. It does not like having an A in columns. Now, we have a way to fix it, right? So as we just saw, as we just learned from the help of this function, we noticed that we can give an object with an NA, like B2, and then we can change the behavior of that NA.rm, right? So if we add a comma and we say NA.rm, and we say equals to true, so the default behavior is false, which we learned from the help of that function, from the documentation of the function. If I change that to true, it will first remove that NA and then calculate the mean. And this should work. This should be, yeah. So if you run that, it works. It gives us back the actual mean of those three values and ignores the NA. All right, so as you're seeing here, we have this function mean. I have this first position that I'm giving the data frame, or in this case, the four values within B2. And then I have an argument that I'm changing, its behavior. If you're not changing the argument behavior, you do not have to explicitly call it. In this case, we are changing, so we had to call the argument name and change the behavior that was false to be true. All right, so what if we actually typed mean B2, comma, true? Would that work? So we're not calling NA.rm, just telling what we want it to be. If we run it, well, it did not work. And here's why. So on this function mean, if you go back to the documentation, the order of arguments that it takes is the first place is X, the second place is whatever you want to do with trim, and the third place is NARM. If we do not call the argument name explicitly, it's going to follow that sequence of the function that we see in the documentation. So in this case here, it is assuming B2 is the X argument, and it is assuming true is the trim argument, which we're not even touching on that, or at least it's not our intention to change that. A way to fix it is exactly how we did above. Oh, hold on. So Comfort has a question. Yes, Comfort.
Yeah, Dr. Pastors, I was going to ask that, let's say we have missing fields in our data sets and we import to R. Will R automatically recognize those missing values as NA?
Yes, that's a great question. So I know that different software code NAs differently. In R, let's say you have an Excel spreadsheet that you have missing data. As long as you have that cell empty without anything, so not a zero, not a dot, not a dash, just empty. When you bring into R, it's going to know that that is an NA, and it's going to assign NA to the cell. Yeah. Awesome. Any other questions, perhaps, about what we're seeing? Okay, so let's continue here. All right, so one way to fix this is whenever you want to change an argument behavior, if you don't want to give all the arguments in between that you don't have to change behavior, which we normally don't do that, all they have to do is just explicitly call that argument's name in the function, right? So let's say we could do mean, if we wanted to be highly explicit with what arguments we're doing, we would say X equals B, comma, NA.rm equals true. Oops. So we're explicitly saying X should be B, NARM should be true, and then this would work again. So it did not work on the previous case because the second argument that the function was expecting was trim, and if we don't explicitly call the argument name, it's just going to assume that's what you're asking for. So calling the argument names, so you don't have to call argument names as long as you're giving things in the correct sequence that the function is expecting. If you are not giving that sequence, then you have to call argument names. To the point that it makes sense that when you're asking for a mean, the first thing that you give the function is the numbers you want the mean of. That is just intuitive, right? But just to make the point here, if I wanted to say mean, and I first want to say NA remove equals true, and then only after that, if the X argument with B, it would work the same way as long as I'm calling the argument names explicitly. All right, any questions at this point? So we talked about objects, we talked about functions, we talked about arguments. And here perhaps is a good point for me to just tell you why I still stick to the assignment symbol, the less than dash, rather than the equal sign for creating objects. Is just, so in Python, you would use the equal sign both as an assignment symbol here and inside of arguments or inside functions for the arguments. In R, I think at least the way that I approach this is I use the assignment symbol when I'm creating objects, and then inside functions with arguments, I use the equal sign. And in case I create a confusion, I want to deconstruct that. You cannot use the assignment symbol with arguments, right? It's just that when you create an object, you have the option. When you are given an argument, you do not have the option. It has to be equal sign. Okay. So we're kind of increasing complexity, right? We talked about different types of objects. We talked about a function. We talked about arguments. Now let's talk about a package and what that is. You already install packages, and if you already work with R, maybe you already know what that is and what it means. But if you never worked with R, a package really is just a bundle, a combination of multiple functions that most of the time, those functions were built for a similar goal or to tackle a given problem or with some commonality behind them, right? So there is a package, for example, that is called ggplot2, which we're going to be using soon here, that has a whole lot of functions that are all related to plotting, right? So they all have, a shared goal or a shared use behind all those functions, and then they get packaged into a package, and that's how we install them. All right, so that's what a package is. I have not asked you to install the package Tibble yet, and so I want to ask you to do that. Here's also a good place for me to show you. If I just run this line of code here that you're seeing right in front of me right now, let me open my console. It's going to basically be ignored by R. R did not try to run it. Because I have that hashtag in front of it as a comment, R does not try to run it. It just ignores it. I want to ask you to, for now at least, delete that hashtag in front of the install.packages function, and then just run that function once. So we get this package Tibble installed. It should be straightforward. I don't expect to have any issues installing Tibble. Let me know if something comes up. All right, a very key concept here is that, yes? Reinstall or maybe reopen, restart. You can try to say no. Yeah, if it prompted you to close R, you can try to say no to that. And I think you should go through. Okay, so a very key concept if you're new to R. We only use the install.packages function in 2 occasions. If it is the first time you're installing that package, or if you want to update that package. So let's say you install this package 3 years ago and they have updates. Then you run this again only at that time. And so the install.packages we use very infrequently, right? Most of the time you're going to use once for that specific package that you're trying to install. Once you install it, I would highly recommend you comment this off or even just delete that install packages from your script, whatever you prefer. Once you install the package, it is going to be installed in your computer, but it's not readily available to be used every time you open R or RStudio. The reason for that is, so R, when you install R, it already comes with some pre-installed packages like base package or stats package or others that already ship with R. And those are always already readily available. You can think of new packages that you install as apps, for example, on your phone. So, there's going to be a point that you've used R for long enough, you're going to have hundreds of packages you've installed. It makes no sense for R to make all those packages available to you at every RStudio or R instance you open, because you may not need all those hundreds of packages that you install. You may just need one of them, maybe a couple of them. So there's the concept of loading a package that we use the function library for that. So we just installed the package Tibble, but its functions are not readily available for us yet. For us to bring that package to life in this RStudio session, we're going to use the function library. And then we're going to call, in quotation marks, Tibble, which is the same name as the package we installed above. So if you type library Tibble and then you run it, now the functions from this package are available to us. We can use that within this environment. So remember, library is to load that package and make those functions available to you in that R window. If you close R and you reopen R, you do not have to install again. You just have to load it using the library function once you reopen that R instance that you're going to work with. Yes, Comfort.
Do we always have to put the quotation marks behind the package in the library bracket when we are trying to load it?
So that's a good question, because so when you're using install packages, you always have to have the quotation marks. When you're using the library function, it's optional for some reason. I just kept it for consistency, but if you just had Tibble, it would have worked the same way. Yeah. All right. Okay, so we just did that, installed, and then loaded it. Okay, so our class today goes until 11:30. I do want to take maybe 5 minutes if you need to take a break, stretch, go to the restroom, get some water, before we continue the exercise. So I'm going to put a timer here for 5 minutes. So we will come back again at 10:55. All right, so let's resume here what we were doing. And actually before we do that, especially here in Athens, who here does not have access to this building? Like this is not your office or your lab, if you can raise your hand. Okay. So for those of you that raise your hand, does your ID allow you to open the door? You can? Okay, so maybe if you want to check on that and let me know, because if you do not have that access, we can work on to give you that access. And I just want to make sure everyone has access to it because it is on your UJID cards. All right. Okay, so now I want to do an exercise. Let me make sure I'm muted. Yeah. Those are online. You can hear me? Okay, perfect.
Yes, we can hear you.
All right, thank you. So let's do an exercise here that I always find very interesting. So I want to create a data frame, and I'm going to show you, let's see, a second different way of doing that with a different function. And I want to call that intro. So please go ahead and type that. So intro is going to be the name of the object where we're going to save this data frame. Give it the assignment symbol, and we're going to use the function tribble for that. So this function comes from the package Tibble, which we just installed and loaded above. If you're not seeing this function, it's either because you did not install the package and or because you did not load the package with the library function. So if you're not seeing this tribble function populate on your syntax recommendation, then make sure you installed and loaded with the library function. Okay, so the way that Tribble works for creating data sets is a little bit more intuitive, at least I think, because the way that we give information to it follows what we rationally would think if it is a simple data set. So I want to have 3 columns here, and the way that we specify those names is a little bit different. So bear with me on the differences. I know this can be a little bit confusing, but let's just go through it. So give it the, I think the name of this is tilde. So this is the wiggly line that some languages have. At least on my keyboard, it is on the top left of my keyboard, right next to the number 1. There is a key with the tilde. It may actually, on your keyboard, it may be closer to the return button, but it should be there. So give it the tilde symbol, and let's give the first column name, which I want to call name. So don't click on names, don't click on any of the syntax suggestion here, just keep it as is. Now we give it a comma. We give another tilde to give the name of the next column, which is going to be height. Give it another comma, and we call tilde again for the last column, which is fav crop for favorite crop. Then let's give another comma and just hit return. So the way that we create a tibble or a tribble, I guess, I'm not sure how to call this actually. I think a tribble is we give the column names, and then each line that we add afterwards is like a row of that data frame. So for this, I want to ask your help. My goal here is to ask for information from 4 people in this class, and I'll be asking your first name, your height, if you know that in the English system or in the international system that works, and what is your favorite crop. Any volunteers here in Athens? Okay, so let's begin here. Yeah, so can you spell that for me? I-S-H-M-A. Okay, and how do you pronounce that? Charishma. Awesome, thank you, Charishma. So if you can also code along with me, we're gonna have to do this for completing the exercise. So Charishma, what is your height? Okay, so maybe let's think, do you know in meters or centimeters? 150. Okay, so let's just put 150. So our height's going to be in centimeters. and then give it a comma, and what is your favorite crop? And if you're not in crop science, maybe your favorite crop food. Yeah. Yeah, like yeah. Okay. Well, do you have like a favorite, perhaps fruit? Maybe like, yeah. Great. Perfect. So that's great. Somebody has a question online?
Yeah, I was just looking at the spelling for the height. I don't know if it's a mistake or maybe it's deliberate.
Oh yeah, my spelling. Yes, that's correct. You're correct. My spelling is wrong. So height. Thank you for bringing that up. All right. So the first row of our data set is this. If we run intro, and if you got your tildes, your commas, and your parentheses and quotation marks, all right, it should have worked. And if we print it, we see that we have a name column, a high column, a favorite crop column, then Charishma 150, great. All right. So now I want 3 more volunteers. Maybe let's take one more here from Athens. Yes. Okay, so Usman, it's gonna be, is that the correct spelling? Yeah, okay. What's your height in centimeters? 182. What's your favorite crop? Maize. All right, perfect. So now let me go to our Tifton folks. Anyone either in the Tifton Computer Lab or somebody that is in the Tifton session would like to volunteer to give your information?
My name is Polly.
All right, so Polly, what's your height?
178.
178. What's your favorite crop?
Mango.
Mango. All right. Okay. Well, I think Tifton has a lot of people in that session as well. So let's take another one from Tifton and then we'll go to Griffin. So one more person from Tifton that can volunteer here.
My name is Ali.
Ali, is that right spelling?
184.
184.
Peanuts.
Peanuts. Awesome. All right, so let's get maybe one here from the Griffin session, which is a smaller session. Anyone from Griffin wants to volunteer?
Can I volunteer?
Yes, go ahead.
So my name is Umar, and I'm the tallest, 190.
All right.
It's
Oh, sorry, I don't know if it was my internet or yours, but I missed your crop.
yeah, it's my internet. So I said almonds.
Okay, awesome. Perfect. All right. Well, thanks everyone that volunteered. Everyone, please go ahead and have these typed out. Again, remember to add your quotation marks where you have to. Remember the numbers do not have quotation marks because they are numerical and not a string. And then make sure you have your commas in the right places. So this is another example. Zach was asking about the spaces in the style guide for coding. We did not have to make all these excuse me, all these break lines here. It would work if we have not done them, but it would have been a lot more difficult to really understand the sequence of things and where something starts and ends, right? So it's just some guides for us to make it more readable. So make sure you run this. I hope you did not get any errors back. If you did, again, make sure you have the tildes, everything that we talked about. If you just run intro now and you look at your console, you're gonna see you have name, height, and favorite crop columns. A Tibble prints a little bit differently than just a frame. And it's not like, my gosh, 2 completely different things. It's just that a Tibble tells you what is the object type or the type of the column that R has identified. CHR is character, and it is seeing this as a character because we gave it as a string. Height is seen as DBL, which stands for double, which is the same thing as numerical. And then favorite crop character as well. And then it prints for us here our information. Okay, so a few things I want to check with you here. So the first one is I want to introduce you. Well, you know, maybe I should take a quick step and ask, anyone having issues with creating this object? Yes. Okay, I think Aminder is coming to help you out. Okay, while Aminder is helping, Aita, anyone else having issues? All right. I don't see anyone else, so I'm gonna assume everyone is caught up. Aita, would you mind sharing what was the issue, just so we can? Okay, so just rerunning worked. Okay. Awesome. Okay, so I want to introduce you to a function that is very helpful to understand how R is understanding the type of your columns. So this function is called class. So we call this function and we give the object to it. So I want to know what's the class, what is the type of this object that we just created that we call intro. So if I call class intro, gives me three classes basically. It's a tibble data frame, a tibble, and a data frame. This is important because this is how R is interpreting the type of object or even the type of column inside of that object. And we're going to get to that in the next step here. This is going to become important, for example, if you just so we can quickly understand here, if you bring a data set that you have your studies that have blocks, that have replications, and on your Excel or CSV or whatever it is, you name your blocks as 1, 2, 3, 4. When you bring that into R is going to look into the column and it's going to think that that's a numerical column where it should not be. That's because block 2 does not mean it's 2 times more than block 1, or block 4 2 times than block 2. It does not have the numerical meaning. You could have named your blocks A, B, C, and D, and you would still have the same meaning of a character and not a number. That matters when we're modeling, because if you give R a numerical column, it's going to model differently than if you give it a categorical or character column like A, B, C, D. So this is just, I'm bringing this up because the function class is going to be one of the ways that you can assess how R is interpreting the type of that object, which will impact how it handles it when it does calculations, when it does plotting and other things. All right. So another important function here is the function summary. So let's say I wanted to get a quick summary of this object intro. So let's call the function summary and ask for this object intro. The way that R shows us a summary by default is any variables that are character is just going to show us the length and that it is a character. So it's not very useful really. But if you have numerical variables like height, is going to give you a statistical summary with minimum, first quantile, median, mean, third quantile, and maximum. This can be really important when you have very long and complex data, or it doesn't even have to be that long and complex. It's just more complex than what we have right here. The reason for that is, let's say you're looking at yield, for example, which has to be a positive number, right? It cannot be negative. And then you look quickly on your summary and you see your minimum. So let's say it's a data set with like 400 rows. So it's not super long or complex, but it's hard for you to really see if there's any issues on 400 rows. Getting a summary will help you to quickly visualize this. So let's say if it's yield and you have a negative value, you know for sure that's a mistake. It could have been a typing mistake. It could have been a machine recording mistake, but it's for sure a mistake because there is no negative yield, right? So a summary function really helps us in some of those instances. All right, so a few more functions I want to show you here that I actually don't use them a whole lot, but I still want to show you because I think it's very classic to introduce these concepts in the first intro to our class. So one of them is the function head. So if we ask head of intro, it's basically going to give us the top 5 rows of the data set. So let's say your data set had 4,000 rows, and you really don't want to see too many. We just want to see the first ones just to get an idea of the structure of the data, right? The head function helps you with that. In our case, doing just printing intro or getting the head of intro is the same because head gives you the top 5 rows. We only have 5 rows total in the data set, so there's no difference. But just to show you here, if you go back on the function head, you could control that behavior by just changing the argument called n. So if I just wanted the 2 top rows, I just change n to 2, and then it just gives me the first 2 rows of this data set. A very similar concept is with the function tail, which is kind of intuitive to imagine that instead of the top 2 rows, it's going to give you the last bottom 2 rows. So if I say tail intro n equals 2, it's going to give me the last 2 ones, which is for Ali and Kumar. All right, so now I want to show you, yes.
So even though head only get 5, can you set n to higher than 5 and get more than 5, or will it only always show the 5?
So if you do not change, so the default behavior of n is, I believe, is 5. We can check that with the help. So if we get help, tail. Oh, the default is actually 6. Yeah, so if you do not change n, it will always give you the top 6 or bottom 6. But if you want to see less or more, you can play with that argument. Yeah. All right. So now I want to show you some concepts of how to subset or perhaps sample a data frame. I do want to tell you that the way I'm showing you is just so you create the understanding of how this can be done. But whenever we really are going to get into sampling, subsetting a data set, we're not going to do this way. We're going to use dplyr and tidyr functions, which if that does not make sense to you right now, don't worry, it will in the future. But I just still want to help you create this understanding of what is happening behind the scenes. All right. So let's say I want just the first row of this data set. So I'm going to print here intro, just so we got a reminder. So the first row is for Charishma. Let's say I just wanted her information, all about her. So I want to know her name, her height, and the favorite fruit in this case. We could use, so right next to the name intro, we open and close brackets. And if you remember from the matrix when we just saw, there are 2 positions in this matrix, in this bracket, right? So there's the X, comma, Y. There's the X and Y position. X represents the row position, Y represents the column. If I want the first row entirely, what I would do here is I would put a 1 in the X position and leave the Y position empty. That is saying, give me all the columns of the first row. So if you go ahead and run that, you should see this, which is the outcome of the first row only with Charishma's data. All right. What if I want just the first column? So instead of first row, I just want the first column. I'm going to start typing intro, open and close bracket notation, and I'm going to ask for somebody to help me here. What would you do here? Comma 1, right? So comma 1 gives us just the first column, which the first column is name. It gave us all the 5 names under that column. All right, perfect. Now let's increase complexity just a little bit. Let's say I want rows 1 to 3 and columns 1 to 3. So let's call intro, open and close the curly brackets. Because I have a sequence, I want to show you a new trick here that if you're new to R, maybe you don't know this yet. If I have a sequence, so 1, 2, 3 means I want 1, 2, and 3, right? In that sequence, we can use the colon symbol. So I'll give 1, colon 3. And if I just select 1, colon 3 and run that in the console, that opens up as 1, 2, 3. In this case, it's really not that much more work if I wanted to type 1, 2, and 3 in a C function, but sometimes you want a lot of numbers in a sequence. So let's say if I wanted 1 through 100, I'm just typing this on my console and not having in the script. But if I just do 1 through 100, it quickly gives me 100 numbers in sequence, or 1 through 100 in sequence. Right, so that's when the colon comes in handy. So if I want rows 1 to 3, That's what I do on the row position. And I do the same on the column position, right? Because I want columns 1, 2, 3, meaning 1, 2, and 3. So if we do that, and if you run it, we see that we got the first 3 rows. So Charishma, Usman, and Polly. And then we got, well, we only had 3 columns. So maybe we should do, 1 through 2, we can do that too as well on the column, just so we see that it's going to give 1 and 2 only. All right, so another level of complexity here, if I just wanted rows 1 and 3, so I did not want row 2, and just columns 1 and 3. So let's give it, that's called intro, open and close curly brackets. So we have the, I'm just going to type out the X and the Y position here. So for the row, how do you think I could retrieve just rows 1 and 3? Notice they are not sequential anymore. I don't want row 2. How?
C function.
Yes, we use the C function, right? So we do C, open the C function, 1, 2, or sorry, 1, 3. And then the same thing on the column position, right? So C, 1, 3. So if you run this, this is what we get, right? So we get row number 1 was Charishma, and row number 3 was Polly, and then column 1 was name, column 3 was favorite crop. All right, so I hope you developed this intuition of having 2 positions. The first one is row, the second one is column. This sometimes comes in handy, but again, whenever I want first row, like given set of rows, given set of columns, from this point on, we're going to be using functions from some packages in the next exercise. All right, so next thing, we're getting to the end of today's class, and next thing I think is a really cool one. So I want you to, well, before we get to this next part, let me actually pull out something here. So I want to print intro. So on your side, you can keep intro printed, and this is what you're going to see. I'm going to change my screen here, so you're not going to see on my screen, but still seeing what intro contains on your side. So let me open the website, the course website. And I want to open a chalkboard so everyone can see both in Athens and online. All right, so here's my question for you. You should be looking at your data frame right now. So if we wanted to make a plot that we want to incorporate all 3 rows in a plot, okay? Let's just think about that. First off, what would you put on the x-axis, right? So if you just imagine, here's my here. So if you imagine a plot, right? And you have these columns here. What would you put on the x-axis? Let's begin with that. I heard, but I didn't really fully understand. Okay, name, right? So that makes sense if we put name on X. So I'm just going to type here because it's going to be easier. So X, we're going to put name. What would you put on Y? Height, right? It's the only numerical variable. Makes sense. Okay, so we're going to put height on the y-axis. And now, how can we incorporate favorite crop in this plot? Let's see, anyone from Tifton has any thoughts? Sorry, can you say that again?
You can put another axis like z-axis.
Yeah, z-axis. I'm not sure how we would do that with a categorical variable. Maybe there is a way, but I guess for now, let's maybe think of another way. Or you know what? Let me do. Oh yeah, sorry, go ahead.
I was just saying maybe as a group, they were gonna have like a legend.
Okay, so what would that legend contain though?
Like the fruits, maybe.
Okay, so the words, okay, we can get there as well. I still want to pivot us to think in a different way, but those are two good solutions. So let me before maybe we think about that. So let's say we put name on X and we put height on Y. How do we want to show this data? Like, if we imagine X and Y, how is it going to show up here? Is it going to be a point? Is it going to be a bar, a line? What do you think we could do?
It's gonna be a bar, and also, can we put both of them in Y? Like usually, I have seen y-axes in front of each other. So maybe we can put y is equal to height, comma, favorite crop.
Okay. So let me tell you this. We could do bar. I do want to show you as a point first because I think that's the simplest next step, and I don't want to bring too many steps at once in front of you. So let's show these as a point. So basically, it would be, if we come back here, we're gonna have names, different names, and then different heights showing up as a point, right? This is just a very simple drawing of that. So now that we established what goes on X, what goes on Y, and what geometry we're using to show, in this case, a point, how do you think we can incorporate favorite crop?
It can be as a color or size.
Okay, so color or size, sorry, what did you say?
C command on Y.
Uh,
Like C height comma.
Oh, okay, use the C function, yeah. Yeah, so I think there may be a way to do that, but I really want us to think more in the direction. Who said color? Ashbin. Okay, awesome. Thanks, Ashbin. So yes, I think color or maybe size, but let's think of color first. So let's say instead of everyone being red here, I can have this person here being green, this one being pink, and then having a legend that includes these colors to show favorite crop, right? So we incorporate 3 columns into 1 plot. All right, so that's how we are thinking about it without coding, right? That's how we are envisioning this to happen. Now, how do we translate that to code? Let's go back here to R. We're going to need to install a package called ggplot2. I don't think I asked you to install before, so go ahead and remove the hashtag, run the install.packages ggplot2 once. After it goes through and installs, just give it a quick moment here. But after it installs, you can just either comment off or just removing that install packages altogether. Remember, install packages most of the time just once, then we need to load it. So let's load now. Oh, yep, a question? No, all right. So let's load this. We just installed it. Let's make those functions available. What function do you use for that? Library, yeah. So library ggplot2. Make sure you run that. All right, so the way that ggplot works, it has this philosophy that you incrementally add components to a plot. There are many different ways, many different packages for plotting in R. So for instance, there is something that you may hear about as base R. There's something that Lattice used to be a very popular package for plotting. ggplot2 is one of the packages that is part of the Tidyverse that was developed by RStudio and is the most popular plotting package that I think beats anything that Python has, for instance. So I do want to show you this, and I'm telling you a little bit of this history because if you are ever trying to do a plot using ggplot, let's say you want to do a line plot in R, and you say how to do a line plot in R. You may get answers back that are not ggplot related. You may get answers of somebody showing you how to do that using base R functions, or maybe using Lattice functions, or maybe other packages. And I'm saying this because in these cases where there are many packages that can be used for the same purpose, if you're searching for help, both on Google or maybe ChatGPT, you need to be explicit. How to do a line plot in ggplot2 in R. You have to say what you're looking for. So that's just some advice there. All right, so the way that plots in ggplot2 work is we start off calling this function ggplot. The package name is ggplot2, then the function name is ggplot. And now we're gonna add a, here at this level is where we're gonna say first, what's the data that we're gonna use for this plotting? So it has an argument for data. The data object is called intro, the one that we created above. Let's give it a comma and break line, just so you can see more easily. It has another argument called mapping. So mapping is what we're going to use to say what column is going to be mapped to what property of that plot. The way we do that is by actually first calling a function that's called AES and stands for aesthetics. Inside of this function is where I'm going to say this column is going to be X, this column is going to be Y, and this column is going to be color. Right? So let's go ahead and do that. So we're going to say X equals to, and I just want to print intro, so or I'm just going to pull up intro. No, let me print. It's not. I just pull up intro. This is what we're seeing. So the column names are, if I want to have name on X, I say X equal name. Notice that if you name your column names with an S plural, you have to use the same way, right? They have to be equal between what's in your data frame and what you're specifying here. Then let's give it a comma, break line. I want to give it the Y value now. I want the Y column to be height. All right, I think for now we can do this and we can just run it. If you have your cursor anywhere here, in between the first G and the last parentheses, it will work. If you're having issues, just make sure you have your commas in the right places. And the indentation here is happening by default, so you don't have to worry about indenting things yourself. All right, so when we run that, we see this plot come up on the bottom right side of RStudio, where we have name on the x-axis with all the names in our data set. We have height on the y-axis. You can see that it's already cutting here the range of this y-axis according to the minimum and the maximum of our data set. So it kind of created this canvas for us. However, we have not asked it to add anything yet, right? So we have not asked to add a point or a bar or whatever it could be. So that's what we're going to do next. If you come here at the end of the last parentheses, let's add a plus and hit return again. At this point, we're going to call a function that the name is geom_point. And for now, let's just run that by itself. So if you run that, you're going to see that now we have a point that is showing that data on this plot. This could have been a bar, and we're going to see bars in another lecture, but point is the simplest one at this stage that I want. Yes, a question, Clifton?
Yeah, I'm having issues. I'm getting the graph. I think I have some error message here.
Okay, so who is that?
Shabir.
Okay, Shabir. So maybe what we'll do, since we're getting towards the end of the class, maybe you can send an email. Well, maybe let's do this. If you we're not going to troubleshoot live in class, but if you can post that on GitHub first, and then we can try to help you there. And if it gets too complicated to help there, then you can connect with Arminder and he will help you out.
Thank you.
Okay. You know what? I don't want you all to be late for what you have to do. We probably need another 10 or 15 minutes to wrap up, but I want to be respectful of your time. So I think we're going to just stop here today. Next Tuesday, we're gonna start class by finishing this exercise. There's gonna be a very easy assignment at the end of it. So yeah, I think that's what we'll do. Before I wrap up, so make sure, I guess, as you're still seeing this, make sure you click the save button, this one, and you know it has taken effect. So right now, if you just look at my screen, you can see that the name of this file is kind of grayed a little bit, like a blue-gray color. If I push save, it changes to white. That's how you know if it's been saved or not, at least visually. So make sure you save your script so all of your changes are saved. And then before I dismiss class, oh, you know what? Something important I was about to forget. Let's take attendance. So the way I take attendance in my courses is going to be through GitHub. Let me go, oops, wrong one, yeah. So hold on, don't leave yet. So the way I take attendance is through GitHub on issues. So I'm going to open here a new issue with attendance January 9. I'm going to submit this new issue. For you to claim your attendance, you have to respond here. You can say here, you can just say hi, whatever you want. Just make sure you write something, you respond to this issue to claim your attendance. If you do not respond here, I will not count you as present. I have no other way of knowing you were here. So if you need a quick refresh, it's github.com/Leo M. Bastos /2025_DSA. That would bring you to the main page of the repo, and then you can click on issues and open this issue here. All right, while you're claiming your attendance, if you have to leave, please feel free to do so after claiming attendance. If you have any questions, I can take some questions now, but if you don't have, you're dismissed from class, and I will see you on Tuesday. Also, I just got I was checking during our break. I don't think UJ is going to be open tomorrow for classes. So be safe, be home, study, work from home, and make sure to be safe. And I'll see you on Tuesday. Thanks, everyone. All right. If anyone has questions, I'll be around. And if not, I'll see you Tuesday.
Thank you. Come and check
Thank
on
you.
me when my problem is.